Good afternoon, everybody. So, welcome to the webinar. My name is Jamie Knowles. I'm the product manager for ER Studio. We've just launched ER Studio 19.2. I'm going to take you through some of the new features. A lot of the new thinking is around how we can extend data architecture for application development. So, strap in. Let's get started. So, let's kick off with the mission for ER Studio. Now, hopefully, many of you are familiar with ER Studio as a product. We've been around for a good number of years now. We are essentially a tool for data architects to be able to produce models of information, and then we use those models to then document and design data assets. And data assets might take the form of traditionally relational databases, and we're now starting to move into other types of data structures. So there's newer databases like Mongo that we're going to talk about, and today we're also going to talk about JSON and hierarchical data structures. And not only that, we're an enterprise tool, so we can support many data architects modeling many different data assets and large installations. So that's our core mission. And the third bullet point there sort of shows how we're now needing to extend that mission. We're no longer just a isolated band of architects in an ivory tower modeling databases. We need to connect in with other groups. I think the last part of this statement here is really important, a company-wide data ecosystem. What we really want is wherever we go in the organization, we're going to get the same answers, the same understanding of data and information. And we need to bring together various different groups. And there's a lot of stakeholders and tribes and groups of people that are involved in the management and governance and use of information. And those groups are really listed here. So data architects we know about, traditionally people looking after modeling, designing, documenting databases. We've got our data governance team, which is a newer group of people, usually based outside of IT. So we've got a lot of data stewards that will be trying to build an understanding of the business's understanding of information, the rules around that information. Is this information sensitive? Are there policies that apply to it, regulations that apply to it? We've then got our data analytics team. So generally working around sort of BI and data warehouses and big data, trying to make sense of information and provide insight to the business to drive change in the business. And then we've got our application development teams. So these are the folks that are writing applications that handle that data, capture the data, produce data. They're also trying to integrate applications and have the applications working together in a sort of broader initiative or ecosystem. So we want to be able to bring together all of these groups of people and the tools that they use to form this single company-wide data ecosystem. And ER Studio is really at the center of all of this. So that's our overall mission. Just to introduce ER Studio as a product. So there's really three components to ER Studio. So we've got thick client data architects, a Windows-based application that our data modelers and data architects are using all day long to produce traditional conceptual, logical, and physical data models. They're generating code from it, reverse engineering, etc., using the tools like compare, merge to go through the gears. The data architects can share their models in the central team server repository, checking them in, checking them out, creating versions. And then we've got our team server core, which allows us to publish those models to a wider group of stakeholders. And there's nice features in there like sort of collaboration and subscription. So if I'm a software engineer working on a particular table of a database for my application, my bit of code, if that table changes by the data architects over here, then the tool will notify me and say, hey, there's a change. And I can have a little conversation around that particular table. We've also got elements of the tool that help us get started on the data governance experience. So we don't declare ER Studio as a data governance tool, but we're going to help contribute to a data governance project by maybe creating business glossaries, creating the terms within them, We can map terms to data models to help build an overall data catalog. So we've got a lot of features in the tool around that area. Maybe we'll look at some of these in a moment. So that's ER Studio as a whole. The next diagram really sort of sets the scene on what we're trying to do with ER Studio. So we're trying to produce a model of the information of the organization and its assets, and we've got different stakeholders involved. So on the diagram before you, on the right-hand side, we've got a data dictionary, which represents all of the assets of the organization, data assets. So we might have documents, databases, flat files. So here I've got a little model of a database, and we can see that in this database I've got 4 tables in the database. There's the name of the table, CMPY. I've got columns against those tables, C_RTNG. Great, I can see the tables are related. So there's a physical model of the database. This doesn't give me much insight. What is C_RTNG? I really don't know. So we use logical data models to give us a more business-friendly view of the information. And for many years now, the traditional logical data model displayed as an entity relation diagram, like we're looking at here, is the de facto way to describe information. So if I'm designing a database, then I'll start off with my stakeholders. We'll have a discussion and say, okay, for your application, what information do you want to put in that application? So we'll say, okay, I need information on company. Okay, well, what types of companies have we got? Well, we've got 2 different types. We've got vendors and clients. Great. Okay, what attributes are there of a client? How do we identify a client? What's a client related to? Related to order. So we'll build the logical data model that faithfully represents the information. And then we'll use that, and then ER Studio will help us to then generate a physical data model that's then closely aligned with the technical implementation of that data, which will be, in this case, we're looking at as a relational database here with tables and columns. So that's an important point to make. This logical data model is faithful to the information, and it's independent of the its implementation. At the top in green, we've got a new part of the model that the data governance team will be using. So we have a business glossary, lists of business terms. Against each term, we'll have the de facto definition of the term. So credit rating score is a term that we use in the business. We'll have a definition, we'll have various flags to be able to classify that. Oh, it's personally identifiable information, it's sensitive, etc. And we can relate these terms together to form an ontology. We can then relate the terms to logical and physical data modeling objects. So I can ask a question and say, well, which databases contains customer information? Oh, this one over here, in a table called CLNT. Great. Where is credit rating score? I can even go to a column and say C_RTNG. What does it mean? What are the rules that applies to it? Well, then take me back to the business term and tell me that it's sensitive and PII, etc. So that's the core of our model. Now, when we're creating enterprise data models, then we might want to split our models into different layers. So down at the bottom, against each particular data asset, I've got a database here, and I've got a physical and a logical model for this particular data asset. And we might have many of these models, one for each of the data assets. What we then might have is a single overarching enterprise logical data model. And we'll have a common definition of important concepts. So customer, this is our standard definition of a customer. We've got all the standard attributes of a customer. We know that how a customer is identified. We know what it's related to, etc. So we can standardize our information, our understanding of information across all of our different models. And in ER Studio, we can link these models together. So I can see from my single notion of customer in my enterprise logical model, I can go and see that it exists in all of these different project models that represent these different data assets. And some customers will then extend that further and have an enterprise conceptual data model. So I might have 20, 50, maybe 100 concepts in there. I'll have perhaps just a basic definition of the concepts and some loose relationships between them. And that's great. So I can see a very high level view of the information of the organization. And again, we can link that down to say, okay, well, company, we've got different types of companies in our enterprise logical model. So That is a standard sort of enterprise data model that many of our customers use and build in ER Studio. And if we connect that to our business glossary and the data governance world, we can link entities, attributes, tables, and columns at any level. And it's really up to you where you do that linking back to the business glossary. So the data governance team can see, well, where is this information? And we can align our enterprise logical model with the business glossary. Again, standard sort of enterprise model, now introducing data governance. If we extrapolate this out down at the bottom, we can support many different types of data assets. So our traditional world is around modeling application databases, standard relational databases. In the newer world, we now want to extend to newer technologies like NoSQL. So document-based NoSQL technologies like MongoDB, which use this sort of hierarchical structure we're going to look at in a moment. So we want to be able to link that in and again create logical models from them. Now, we might also want to be able to support JSON messages. So between different applications, we might have lines of communication between those. We might have an enterprise service bus or a middleware layer with lots of JSON messages flying around. So again, we might want to understand the information in those messages, or we might want to design them in the same way that we design any other data asset, a database, for instance. We've got our data warehouse and we've got BI in here as well. So all of these things we want to be able to understand and maybe connect into our enterprise logical data model. So if we have a model like this, we can start to ask those really important questions. So customer information, where is it stored and where is it moving? So I can see that it's stored in these application databases. We've got Mongo database as well. It's in the warehouse. It's in our BI reports. We've also got customer information flowing between different applications via these JSON messages. So having this sort of model gives us a lot of power to really manage our data. Another benefit of this is with ER Studio now being able to generate these hierarchical structures, I can generate one from the other. So we've got some customers, for instance, that say, okay, we want to build a common messaging infrastructure between our applications through JSON messages. So where do we start? First of all, we need a canonical model for all of our JSON messages. So we've got customers that are perhaps starting off going through their application databases, reverse engineering, creating physical models. From the physical models, we then expand the physical names and create nice logical models. We can then say, well, which of the entities in this model do we then want to promote and reuse in our enterprise-wide logical model? And we can use ER Studio's compare merge capability to then select individual entities and promote them and copy them into the enterprise logical model, building these universal mappings as we go. So we keep going through our application databases, building up logical models, adding to the enterprise logical. And then at some point, we then say, okay, we've now got a good, solid, canonical model for the organization. And then we can come back down through the gears. Now, as usual, if we're designing a database, we can use our enterprise logical model. So we might say, for this project, I want customer and order information. So I'll select these two entities, use compare merge to copy them into a new project's logical model. I can then perhaps tweak the logical model a little bit specifically for the purposes of this project, or keep it vanilla. From the logical model, we can now in ER Studio then generate a physical model for our JSON messages or our Mongo, and that then allows us to standardize the messages. We're using standard descriptions of objects, standard attributes, standard relationships between them. So wherever we go, we've got now some standardization across our information. And also we can see, well, where is our information, what rules applies to it, etc. So that's our mission. Let's have a little demo now. So what I'll do is take you through a journey in ER Studio. I'm going to start off, we'll start talking about MongoDB specifically. I'm going to hop across to Compass. Now, hopefully everybody's familiar with Mongo. I'll do a little bit of a sort of brief introduction. So MongoDB can be used like a standard database, but it's a document-based NoSQL database structure. So we can host it either on the cloud with Mongo Atlas, or we can have local instances. In this case, I'm using Mongo Atlas, so on the Mongo cloud. I'm looking at a particular database called LibraryDB. in my database, I've got 4 collections of documents, and collection equates to a table in a standard relational database, and a document equates to a record in that database. If I go and look at one of these, let's look at publisher, for instance. Each document is stored within Mongo as a JSON structure. So if I expand the JSON structure for this one document, I can see that my Mongo document has got an ID. We use a surrogate key, which is a GUID. And then we can store all the fields of this particular document. And because it's JSON, we have a hierarchical structure. So inside this, I've got a field called address, and then my address is an object which has fields within it. Pretty straightforward. And if I go to book and expand one of our book documents, so I've got a book called The Yellow Meads Vastadel, various properties. My book has chapters, and in this case I've got 2 chapters. The first chapter has got properties, it's called the proposal. A chapter then has sections, which is an array of sections. So my JSON structure here is very much hierarchical. So immediately it's different to a relational database because of this hierarchical structure. Mongo does support relationships, foreign key relationships between documents. So each document has this surrogate key, this GUID, and I can relate them together. So that my publisher collection that I was looking at, so this book relates to a publisher through this GUID. So that's the structure of Mongo. Now, if I go to ER Studio, we can reverse engineer this. So I just hit login. So I can put the connection string into my Mongo database, which is on Atlas in this case. I can go and select a particular database. So there's LibraryDB that we were just looking at, and then I can reverse engineer and use fields in a moment. So I hit finish, going up to Atlas, and here is the physical model that I was looking at. Now, for those of you who have seen ER Studio and been using ER Studio in the past, you'll notice something that is immediately different. So yes, we have our basic objects, which are the collections, or which look like tables in our Mongo database that we're looking at. But now we have this hierarchical structure that we can see in the physical model, and we can expand and contract these JSON structures. Everything else is pretty much the same. So our foreign key properties are shown there very nicely. So within my checkouts structure, I've got some fields that are foreign key relationships to libraries and to patrons. So my book is being checked out to libraries and patrons. Pretty straightforward. Now, what we've got behind the scenes here is a sort of pseudo relational model. And if I go to diagram, display objects, rolled up contained objects. Again, this is new. So I can change between that sort of rolled up hierarchical view and this sort of objects-based view. And if I just jiggle them around, I've got a one that I've laid out previously. Then in my Mongo physical model, I've got the notion of collections and nested objects. Now, we've had support for Mongo for some years now, but we've done a lot of improvements to this. That nested view that I showed you there is very much a new feature of 19.2 that's just come in. It makes it much easier to just visualize the hierarchical structure of Mongo. So previously, when I reverse engineered, I get this type of view here. The collections are shown with the square edges, the nested objects underneath with the round edges. Collections will have the surrogate key. My containment relationships are drawn with these little diamonds. So this view here we've been able to do for some time. The new functionality allows us to switch between this rolled up view and the intermediate view. So that's the first thing that we've done. Now, the next thing is once we've reversed engineered our Mongo model here, we'll automatically create a logical model from it. Now this one here, I've gone a bit further. We go back to the one we actually reversed engineered. I go to my logical model, then this is what it would give us. It would give us all of the entities. We don't know which of these properties are primary keys. So if we were going to do anything further with this logical model, then I might start going through and promote some of the attributes to primary keys. But this logical model has been generated from that physical view that we imported from Mongo. What I want to do now is to show you the same sort of thing happening when we reverse engineer a JSON structure. And then we'll talk a little bit more about this sort of conversion between logical and physical. So same sort of thing. So Mongo is based up of collections of JSON files. Now, what I have now is the ability to import from a JSON file directly. If I go and select a particular JSON file, JSON instance, we could import Mongo JSON and hit OK, and it's going to import the JSON model. In this case, we've got a structure here. We've got a JSON file with an array of book objects, and the book objects contain chapters and sections and checkouts and such like. So exactly the same with Mongo. We've got this hierarchical structure, and we can switch between the rolled up hierarchical structure and this sort of pseudo relational view, which is quite useful. Again, it will automatically generate a logical model from it. Now, one of the features in the reverse engineering, that import mechanism, was as it goes through and finds objects, repeated objects, it will try and collapse those together. So just going back to our book example, I'll go back to the physical. So address, for instance. Now I'd got various Mongo collections that all had address fields within it with a set of subfields inside the address. So there's a little option there to say wherever I find an object, I will try and collapse them together into one repeated object. So when we're documenting JSON structures in Mongo or instance files, we really want to try and understand sort of where information is standardizable. So it'll collapse together all these address objects. It's a useful new feature. This is the JSON file that we imported. This is the logical model that we got from it. One interesting scenario here, and again, for those of you who've been using ER Studio, this should be pretty standard. I reverse engineer data assets. It creates a logical model. The logical model is faithful to the information. What I could do is start going through each of my entities here, and I can say, well, how do we identify a book? We can start adding things to the primary key. So identify a book by its author and its name or title. So creates the primary key from it. The tool will then go through and start resolving the foreign key relationships based on those key changes here. So you can see now that my book, author and name, through these identifying relationships that it's interpreted from the JSON, it's now propagated the primary keys. And I could polish this model up. And then what I can do is say, okay, so from that JSON file, what I'd really like to do is to create SQL Server database that's going to hold all of that book information. So I can say, well, now from the logical, generate a physical model for my SQL Server database, and boom, there it is. And then from this physical model, I can then say generate database, and out comes the SQL code that I can give to my SQL Server database to create that table. So in only a sort of small number of clicks, potentially, I can go from a JSON file, it might be a JSON instance file or a JSON schema file, created my physical model, created my logical model, I then updated my logical model with some information that my database is going to need, like primary keys, and then generated all the way through to the code. And there's my database. So I can then potentially take an ETL tool and then load this JSON file into that database. So that's one scenario that's quite useful. The next scenario I want to take you through is the forward engineering journey. So again, the starting point for data asset design should be starting from a logical data model. So here is a fairly standard logical data model. We've got entities, the entities have got attributes, and they've got primary keys. From this, I can immediately generate a SQL Server database, an Oracle database, whatever I like. So what we want to do now is generate a hierarchical structure. So we can go through and generate a Mongo database and or a JSON structure, and soon a Google BigQuery hierarchical structure from it. Now, in all of these hierarchical target models, we've got the notion of nesting and denormalization. So what we want in our target database is to be able to say, well, book, these things, chapters and sections, what I want to do is to have them contained within the book. So these will be collapsed into book as nested objects. The notion of address over here for performance, instead of having a separate collection in Mongo, what I want to be able to do is include the address inside the publisher. I also want to fully denormalize this. I want to put address inside library and inside patron down here. So what we can do in the logical model, we've added in some new properties. So again, at the core of it is a standard logical data model. So now what we can do is we've got a little property here in our logical containment, and we can specify that this relationship means that address is contained inside publisher. And we can also control the direction. So in my standard non-identifying relationship here, then the parent entity is address. Well, we want to switch that around. So well, publisher will contain addresses over here, and book and chapter. So book is now my parent entity in this relationship. And here I want to say that book will contain chapters, and the parent will be the container in this case. So in the logical, I can just put a very simple property that allows me to control how things are going to be contained in my target physical model. And this will be whatever hierarchical structure I use. So this will be either Google BigQuery, JSON, or MongoDB. So next step is to generate my physical model. I hit generate physical model, exactly the same process that I use for a database. We'll call this Mongo1, and we'll select from the list Mongo. Now it says here MongoDB 4.x. When we first started developing this new functionality, I think 4.4 was the latest version, and then halfway through the 5 was released. We've tested it against version 5, we've tested it against Atlas, it works just fine. So what I can do now is a few little rules. This little set of properties did exist in a previous version. We've added in this new rules-based approach for how do we decide on which of these entities here will become collections in my Mongo and which ones will become rolled up nested objects. So I'll explain what's going to happen in a moment. Let's hit finish. What it's done now is it's generated a physical model for my Mongo database. And let me explain what it's done. The first thing it does, it says for every entity in my logical, create an object on the screen and take away any sort of primary key properties, just make them all fields in my my target objects. So that's step 1. Step 2, it goes and creates the lines between them. So based on those containment flags in my logical, it'll decide, is this a containing relationship? So yeah, book contains chapter, chapter contains section. Great. Here, this wasn't a containing relationship, so it's created a referencing, a Mongo referencing relationship. Great. The next step, it goes through and does a parse and looks at each of the objects and says, am I contained in anything? If I am, then make it a nested object. So section is contained in chapter, it's a nested object. Chapter is contained in book, also a nested object. We can tell because it's got a little round border to it. Book is not contained by anything. Okay, so it's now got a square edge. So that makes it a collection. If it becomes a collection, we give it a surrogate key, this underscore ID, the Mongo identifier. Then the last pass, it goes through all of the objects and says if there are any referencing relationships, then propagates foreign key fields to the target object, so patron ID and library ID. So that's the process that it takes. I can then again visualize this either using this sort of pseudo relational type structure, or I can say switch it across to my sort of more Mongo friendly rolled up view here. And that now looks more familiar to what we're going to get in our Mongo structure. And then the last thing is I can generate out some Mongo test code that I can use. The same sort of process is used with JSON. So I'm going to generate my physical model for JSON now. JSON 2. Select JSON from the list. Find it. IJK, and to spell Jamie. There he is. Oops, missed. JSON instance. Oh, third time lucky. There we are. And then I can just generate physical. Again, it's going to create this pseudo relational view. It's telling me that in JSON, these referencing relationships aren't really valid. So they're there for documentation, but they're not going to really do anything. If I switch across to my hierarchical view, there it is. There's my top level JSON objects. Now, the next thing is I might say, well, okay, so this is where the sort of polyglot modeling approach comes in. I want to make a decision as to what is the context or perspective of this particular JSON file. Is it from the perspective of the book or the library or whatever? So what I could do is go back to my logical and start to tweak these little containment flags that we were looking at earlier on. And then I can use compare merge to then propagate those changes back to this model here. Alternatively, I could just sort of tweak this model and add in some containment relationships. So I could say that, well, books contain publishers, yep. Libraries contain patrons, and libraries contain books. And there at the end of it is my single JSON object that I was looking at from the perspective of library. And again, I could create many different physical models with a different sort of polyglot approach where different objects are the context object. I can go into my my JSON model, and at any point I've got a little JSON tab that's new, and I can see either the JSON instance file to give me some sort of dummy sample data, or I could say show me the JSON schema view, and I can select either the latest draft 2012, or the most common draft, which is draft 7 of the JSON schema format. And there it is. So there's my JSON schema file. And I can use this JSON schema file then to validate my JSON instance messages. So there it is. And from that, I can then generate the file straight out. So if I'm a developer, an application developer, and I want to design a JSON structure or a Mongo structure, then I can take the good work of the data architects. I can start off with a logical model. Maybe the data architects have already given me a model with this logical model in it already. And then I can use the tool to then design my JSON structure or my Mongo structure from it. I can control the sort of the nesting and the perspective of my JSON file, and then generate my file. As I'm doing this, then I'm storing models of it. So my JSON structure is nicely documented. And if I created the logical model from my enterprise logical model, then I've got those universal mappings that allow me to sort of trace up and down and say, well, where is this? Where did this field come from? What does it mean back at the original context? If I want to change my notion of address across all of my different messages and my databases, I can see which models it used within. So it gives me that sort of overall overarching management capability. What I can also do, and if I check this model into my repository, and I'm just going to open one that I have earlier on, hopefully, there we go. So here I've got a physical model that I've created for Snowflake database, and you can see the little padlocks is telling me that this has been checked into the team server repository. And what we have with the repositories, we now have access to, I'm not logged into team server. If I was logged into team server, then it would present me a list of business terms, and I can map my fields in the database or my fields in my JSON to the business terms. So going back to that model that we were looking at earlier on, if we can get it to come up on the screen. Jamie. So again, what I'm looking at is a field in my JSON message, credit rating score here. I could have it directly mapped to my business glossary or mapped through the logical, through these universal mappings. And I should be able to work my way back to the business term. So this is really helping me document my, my JSON messages. If I have actually been through that process, then Team Server will help me visualize that. Let me just give you a quick tour of Team Server. Fire it up and bring it over onto the screen. Here it comes. So another new feature in version 19.2 is we've added in the notion of a data catalog. So before you would have seen data sources at the top. And if I click on that, you would have seen a view that looks a little bit like this when it comes up. And I've got a list of things. It doesn't make a huge amount of sense. So what we've done is we've done a lot of work to sort of polish up the sort of the view to make it more business friendly in our data catalog. So what I've got here is a list of groups of different types of data assets. So I might say, well, I've got a enterprise service bus with a whole series of APIs in there. So I've got a library management API, and here I can then start to drill down through all the different fields that we've just been looking at. And I should be able to go to any of these, and I haven't got it mapped. But what I should see is a little business term. So if we had related this field to a business term, it would be listed here. I could click on it and then go to the business term and read all about what are the rules, what's the standard definition of a book, what are the policies, is it sensitive information, etc. And we've applied this both to our sort of JSON messages and our Mongo structures, and also to standard relational databases like SQL Server. So I've got a model here. Now you notice, so on my database server called C7, whatever it is, I've got a number of SQL Server database instances. There's training DB, and then it's giving me a list of all the tables here. And I've got switched on, give me the logical names. If I click on employee, the actual physical name in the database is called EMP. Now business folk wouldn't really want to see EMP, so we display using the logical business names. We've got a nice simplified view. So for this table called EMP, logical name employee, there's the definition of it. And again, there's our related business terms, and I can sort of open up these terms and then read all about the term. So great, that's what the standard definition of an employee is. Brilliant. In my human resources glossary, it's critical sensitivity, PII flag equals true. Brilliant. I can also hop across to Calibra. So this model has been published to Calibra. This is functionality that came in version 19.1, being able to synchronize the business glossary and the data catalog of ER Studio with Calibra. So I could see the same sort of model in Calibra. So potentially all of those JSON messages that we've been designing, all those Mongo databases that we've been designing, along with our SQL Server databases, I can now publish those models across to Calibra with their mappings to the business terms and contribute to our data governance experience. Oh, I think that was the end of my demo. Let's do a recap and see where we're at. So, in summary, what we can do with ER Studio with a new capability is we can build standardized models of information, and we're going to use our logical data models to do that. We might have a single de facto canonical enterprise logical data model with standard definitions in there. Our standard definition of employee is the primary key of an employee. We have alternate keys when there's all the standard fields of an employee, standard relationships. We can standardize our information. We can then use that model to then generate our physical models. So there's our enterprise data model. We can connect those models to our data governance program, so mapping business terms to entities, attributes, tables, columns, objects, fields, and then being able to publish all of that to our data governance tool. We can design and document data assets. So we've seen being able to document and design standard relational databases, SQL Server, etc. And now we can model hierarchical structures. The new functionality we've just released gives us this nice new visualization of those hierarchical structures, of those rolled up views, which is a lot more faithful to the end products. We support in 19.2 JSON and MongoDB. We're just about to release support for Google BigQuery, again using the same capabilities there. We can generate the physical model from the logical. We can go the other way. We can reverse engineer to document and then generate a logical model and expand the logical model using standard entity relation diagrams. And if we do all this, we get our united data ecosystem. So no matter which group that we're in, whether we're our team of data architects, our data governance teams with data stewards, or application engineers, then we're using standard definitions of information, standard structures, and contributing to a single model where everything's joined up. So I've got that traceability. I've got the documentation built in. I can then do the impact analysis. If we change our understanding of customer, then what's going to be impacted? Where is information on customer stored, etc. And when I say application engineers, this could be engineers that are developing code and using JSON structures within an application itself, or it might be application integration engineers. I'm trying to build a common messaging infrastructure that's JSON based. I might also be building something like a data streaming service using Kafka. I might be serializing my Kafka messages using JSON. But all of these, I'm using the same sort of approach. So that's as much as I was going to say. Let's go on to questions. Tim, do we have any questions that are out there at the moment?
Yeah, we have a couple, Jamie. One was early on, and I think you got to it. Krishnamurthy asked, does DRStudio support databases with different nested structures? And I think you showed the Mongo and the JSON on that. Do you have any further comments?
Yeah, as I said, sort of Google BigQuery is the next one that we're working on, which also supports nesting. So BigQuery, they really sort of press home the need for denormalization to increase performance. Same sort of thing we do in Mongo. So we're using exactly the same approach to Mongo. So that's coming out in the next couple of months. And wherever else there is hierarchical structures, then we'll be using the same sort of approach again, that nice sort of nested rolled up view that we're looking at. Just sort of whiz back to it.
Andy asked the question, I think you touched on it, you might flesh it out a bit for him. How does handle JSON that's not consistent, meaning attributes are stored in some but not all the documents? Does it sample X documents to infer the schema? And I think yes.
Yeah, that's a great question, and we made sure that we did. So that is a really sort of valid point. So I might see a JSON object with an array of sub-objects. So I might have 10,000 sub-objects. Each of those 10,000 objects might have different attributes. So we made sure that we poll all 1,000 of them and concatenate together one definitive list of fields in there. Likewise, we also go across, there's a little option when you reverse engineer to say combine repeated objects. So if I find address like I have here inside publisher and library and patron, then there's an option to say combine them all together. So I might then concatenate all the fields across all instances, across all three collections to give me that definitive set. So I've now got a standard definition of address that I pulled from the Mongo structure.
Great. Yeah, we just got a few minutes more. I see a lot of questions coming in now that we're answering, so we'll try to get through them. Krishnamurthy asked, can a reverse engineer from databases? I gave him the link. He says, can we do BigQuery, Databricks, SQL, Mongo, Cassandra? You've seen SQL Server and Mongo there, but Jamie, you could maybe talk to Cassandra and BigQuery and Databricks.
Yeah, so with ERStudio, we've kind of got 3 levels of support. The basic level is if the target supports ODBC, we can connect to it and create some understanding of the data within it. We've then got, and I'll skip to the other end, which is our full-blown support, our native support. So I can reverse engineer an existing database, and then either through ODBC or with a native connection, we've got support for a whole raft of different database products, native. And we do as much as we can to support all the features of those different platforms. And then the last level is using our meta wizard bridges. So you can see I can import from external metadata. It has to load up a whole sort of Java library here, so it's a little bit slow. And we provide support for a whole range of different technologies like Cassandra, and we got some ETL tools, and yeah, the list is pretty huge on what we support. And that's just for reverse engineering. So when we're forward engineering, we don't necessarily support all of these different technologies.
Great, great. I'll go ahead, Chris Murthy. I'll put in the link in the chat here to our meta bridges import site. And these bridges are fully, all the bridges are available on our Enterprise Team Edition, I might add. So let me go ahead and put that in here. While I'm doing that, Jamie, I could answer that next one for you, Chris Murthy. Does it create the logical model automatically during a reverse engineer? Yes, it does. There's an option to do physical only, but it's not on by default. So it'll always by default give you reverse and, sorry, the logical and the physical model. Can you please show the hierarchical structure once again, if okay? I think you just went through that.
I think we just had that there. Yeah. And we've done a lot of work on the sort of the last use case where I'm a developer. I just want to rattle out some JSON. So we've done a lot of work on the sort of in-place name editing here, where I can sort of edit the address, add some minute fields in there. And you can see I can select now the data type of that. And as I'm editing address, because address is reused across these other objects, it'll replicate it across. So we've done a lot of work on the sort of in-place editing of physical models using this new hierarchical structure.
Yeah, and I'll jump to one the end question there for Sandeep. Yes, or sorry, Chris and Murthy. Does it show multiple level on nesting, deep nesting? And I think Jamie showed you that with the book example. So the answer is yes there. Can you elaborate, Jamie, on the support for Data Vault in ER Studio?
Yeah, that's a good question. So we've been having a lot of thinking about this. So one of our competitors has got some pretty basic support for Data Vault. Data Vault lends itself very well to automation. We've got our Warescape tool that is all rules based. So it takes a model of a source data asset. You apply business metadata to that model, and then based on the metadata, it will then generate hubs, satellites, links, etc. Between them, and then deploy that to the database, and also deploy the ELT scripts. So it automates the whole lot, and it works really well for Data Vault. We've had some customers that say we want to be able to model Data Vault manually in ER Studio, and we're thinking about sort of how we can perhaps do something intelligent, a bit more than some of our competitors are doing, which is just sort of very basic templates. There is a paper on the community about how you can create some macros that will help you sort of standardize the sort of creation of hubs, links, and satellites and stuff. It's an area that we're going to think about in the future, but no promises yet.
All right, Jamie, did you answer the question on how soon on Google BigQuery? Did I miss that answer?
2 months. August is the target date for that. Yep.
Okay, probably just have a couple minutes here for a couple questions. We got a complex one here from Richard. We are commonly encountering hybrid DB databases with relational third number form on a star model with columns containing JSON documents that are in the context of the record, like we saw. Can ER Studio model these JSON documents embedded in JSON columns?
Right. Now this is a cracking question. We're seeing this a lot. So there's a lot of database products out there that will allow you to type a column. So rather than just a sort of simple atomic type of string or decimal, you can create a JSON field. Now this is very early days, but you can imagine that if the tool was to be able to support visualization of hierarchical structures, and we have the ability to import JSON, wouldn't it be great if I could reverse engineer a SQL Server database? or a Snowflake database or an Oracle database that supports JSON typing. So here I've reversed engineered my SQL Server database. There's all the columns. Wouldn't it be great if we could do a second pass that says, oh, this column here called checkout is of data type JSON. If we did a second pass and go and look at the data inside that column, and then, hey presto, by Jingo, we then create model of the JSON within it. That's an idea, and it's something we're very much talking about and moving towards. Don't have a date on it yet, but we're working on it.
Okay, great. I know here's one near and dear to your heart. Yeah, you might want to talk a little bit. Is there a plan for IDERA cloud version of Data Architect?
Ooh, one, yeah. So like many of our competitors, these products have been around for a good number of years. They are jam-packed with super exciting features and functions. We currently only run on Windows. The plan is and we're starting the work on this at the moment, is our team server product that we're looking at here, to be able to extend this to be able to do more data modeling inside team server. So you'll see as new features coming out in the next year or two, where we can start sort of nice high level data modeling inside team server, and then gradually over time, all the functionality inside Data Architect, we'll move that across to team server. We're not going to do it quick. We're going to have to keep nipping away at it. Data Architect is a fabulously powerful tool.
Just a couple last questions, gang. Here we're out of time. Maybe we can maybe send answers later on these. Don't have a Mac version right now, Sandeep. You can see that Jamie's actually displaying on his Mac using a Mac emulator, but we don't have a Mac version of Data Architect.
No, so that'll be where team server comes in. So hopefully we'll have a nice web version of Data Architect that has all the functionality. You can install that, and then all your Macs and Google Chromebooks and all those sort of things will be able to access team server and do your data modeling. And that version of team server will be able to host at some point either in your private cloud, or maybe we'll set up a public cloud version as well.
Probably from one of the last ones here, Jamie. Can your studio support multidimensional models? And we've seen that, and generate ETL scripts. So you can talk maybe to the ETL side of that.
Yeah, so we've got the ability to draw multi-dimensional models, and I've got to remember where the setting is. There's a setting somewhere that says, I've forgotten where it is, to switch it to a dimensional view. It's really a sort of a graphical approach. For ETL, we do have the ability to create these data lineage diagrams where, so here perhaps between my JSON and my Mongo database or my SQL Server database, I could create a data lineage view that allows me to select source tables and target tables and create, so from book to my Mongo book over here, I can then create a transformation and a data stream between them, and there we go. And then I can select which fields there are in this particular data stream. We can't generate any ETL code from it. We can reverse engineer some ETL products and create these sort of views to document.
Okay, I think we're out of time there, Jamie. I might mention to the audience what you've seen Jamie display here today was the Enterprise Team Edition with Team Server Core. That functionality is in our the full version of the product. If you happen to be at a customer site that didn't have some of these features, please contact your sales executive there at sales at IDERA. Have a conversation with them. Us on a systems engineering team, be happy to give you a demo of these features or work one-on-one with you a little bit to answer any questions you might have about that increased functionality. So please reach out to your sales and exec if you need that information. Thanks a lot.